This is section 3.4, Graphs of Polynomial Functions. In this video, we're going to go through number 39 in your book. In this problem, it's asking us to find the zeros and the multiplicity of this function. So first, quick review of what zeros and multiplicity are. We were given a function like this, and we were asked to find the zeros. They're really just asking us to find the x-intercepts of this function. And remember, x-intercepts are wherever y equals 0. So I'd set this equal to 0, solve for my x, and when I do that, I'd end up getting that x is equal to 2. And this is my 0. Next, to find my multiplicity, that's just how many times does this 0 occur. So when it's written like this, it's kind of nice because the multiplicity of this 0 is just the power that this quantity is raised to. So in this case, since this quantity is raised to the 4th power, my multiplicity is equal to 4. I'll spell it out. There you go. So now we're going to just apply this to this function here. So again, they're asking for my zeros and multiplicity. First step to find my zeros, I'm just going to find the x-intercept by setting my y equal to 0 and solving. This looks like a pretty complicated polynomial, but it becomes a lot easier when you take out your common factor. So my greatest common factor among all these terms is x to the 3rd. And when I take that out, I'm left with 4x squared minus 12x plus 9. And now you might see how you can factor this out and solve for my x's. I can set this term equal to 0. And then when I set this part equal to 0, I see that I can factor this down into two binomials. When I factor this down, this becomes 2x minus 3 times 2x minus 3. And you might notice that I have the same term here, so I can actually rewrite this as 2x minus 3 squared. All right, so now I set both these terms equal to 0 and solve for my x's. Over here, I'll get that x equals 0. And on this side, I'll get that x is equal to 3 over 2. All right, so these two values are my zeros. Next, to find my multiplicities, I just look at the power that they were raised to. So in this case, since it was x raised to the 3rd power, my multiplicity is equal to 3. And in this case, since my quantity was raised to the 2nd power, my multiplicity is 2. And that's it for this problem. So, quick recap. First, to find the zeros, we're just finding the x-intercepts. So we set our y equal to 0 and solve for our x's. In this case, we took out a common term and then factored it down into two binomials. And then we set each part equal to 0, solved for our x, and got these values as our zeros. And then to find our multiplicity, we just looked at the power that it was raised to. So here is raised to the 3rd power, so our multiplicity was 3. And over here, it was raised to the 2nd power, so our multiplicity was 2. But other than that, that's it. I hope you found this video super helpful. The concepts covered in this video are true no matter what pre-cal class you're in, but in case you're interested, all the sections and problem numbers referenced in this video came from this lovely textbook right here. Remember that if you're a Baylor student, we offer free tutoring on the 1st floor of Sid Rich at our Success Center. You can either schedule an appointment online or drop in during our business hours for free tutoring in pre-cal, calculus, and a whole lot of other subjects as well. For more information, visit our website.